to this problem before we move on to parabolas. So the first thing you do is move the 12 over to the other side and group the x's together and the y's together. So I'm going to move this 4x over here and the 6y, or the y squared with the 6x. So I get x squared plus 4x plus y squared minus 6y, and then I add 12 to both sides, so I move the 12 over here. Okay? All right. Then I need to complete the square for each of the x's and the y's. So I'm going to complete the square for this x and complete the square for this y. Right? So I take half of 4, which is 2, and square it, which is 4. So I'm going to add 4 to that side. Then I take half of 6, or negative 6, which is negative 3, and square it, which is 9. So I'm going to add 9 to this side and add 9 to that side. Okay? Then I add those in, so I get x squared plus 4x plus 4 plus y squared minus 6y plus 9 equals 25. And remember, the reason we complete the square is so that we can factor it into perfect square trinomials. So, move this down a little bit. So this becomes x plus 2 squared, and this one becomes y minus 3 squared, and it all equals 25. So now I have it in standard form, right? So this is standard form, because it's x minus h squared plus y minus k squared equals r squared. So what's the center? Right, negative 2, positive 3. And what's the radius? 5, square root of 25. And then I graph it, and that gives me negative 2, 3 is negative 2, up 3. So that's a center, and the radius is 5, so I go over 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So there's my circle. Okay, we're good at that? Okay, then let's move on to parabolas today. Okay, oh, one more. Okay, no, yeah. So there's two ways to write the standard form of parabola. Remember earlier we said if I give you like y equals 3x plus 1, you know that's a, what's the graph of 3x plus 1? It's a line. If I give you x minus h squared plus y minus k squared equals r squared, you know that's a circle. And if I give you ax squared plus bx plus c, that's a parabola. Okay, and a parabola is that U-shaped graph. Okay, you did some of this in Algebra 1. So this actually should be y equals. Okay, now we're going to do, there's two ways actually to show the standard form. Or two ways to show the parabola. One is standard form, which is ax squared plus bx plus c, and the other way is vertex form. Okay, and that's a little bit easier to graph. So if like someone comes up to you on the street and says, "I need you to graph this parabola," you say, Okay, I need it in vertex form because it's easier to graph in vertex form. It's easier to manipulate for other reasons in standard form. Okay, vertex form, remember I told you HK always stands for the center, like H and K is the center of the circle. H and K is in the very center of the parabola, right? And we call that very center the vertex, okay? It's, why won't that go away? There we go. It's the dot at the very bottom of the parabola, because a parabola is symmetrical. Like this side is exactly like this side. Okay, so there's a mirror image of that point over here. There's a mirror image of that point here. There's a mirror image of that point there. It's symmetrical around the center, and we call that center the axis of symmetry because that's where the parabola is symmetric, around that point, around that line. Okay? And I abbreviated AOS, axis of symmetry. So every time you see AOS, that's what it stands for, axis of symmetry. So the vertex is the one point on the parabola that doesn't have a mirror image because it's right on the axis of symmetry. So it doesn't have a mirror image because it's right in the middle. Okay? And we call that point is going to be HK. And let's see what else do I need to know. That's it, I think. All right. So when we graph the parabola, we need to know what the vertex is, and we need to know like two other points so we know how to make the U. Should we make it really fat? Should we make it really thin? What should we do to make that U? So we're going to find the vertex, and we're going to find one other point to help us draw it, to help us sketch it in. So one thing you should know, it's a quick check for your graph. When A, this number out front, because A, B, and C are all going to be numbers, just like in y equals mx plus b, the m and b are always numbers. The A, the B, and the C are all numbers. When this number is positive, like positive 3, positive 2, positive 1/2, anything positive, the graph of the parabola is going to go up like that, like a smile, positive smile. And when A is negative, like -4, -3, -1/3, the graph points down. It's negative. Frown. Get it? Negative frown. Yes. Yes. Okay? And so can you see the vertex is right there, right? And if it's going upside down, it'd be right there. So when you look at the vertex, the parabola is going down, 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 down till it hits that, and then it starts going up. So it's the very lowest point on the parabola, or in this case, it's going up, 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 up till it hits there, and then it starts going down. So when the parabola is upside down, that vertex is the very highest point. Okay? So like pretty soon we're going to be doing real-life applications. If we want to know, like, if I throw a ball in the air and I want to know what the highest point of the air, I'm looking for the vertex. Because the vertex is going to be the highest point the ball reaches before it starts going back down. Or a diver dives off the board. I want to know the highest point. Well, it's going to be the vertex. Okay? All right. So, like I said, we're going to do standard form first because vertex form is way easier to graph. So, all right. So the first thing I need to know to draw my parabola is I need to know the axis of symmetry. I need to know what it's reflecting itself around or what's it symmetrical around. So the formula for finding the vertex or finding the axis of symmetry is x equals -b over 2a. Because remember, vertical lines are always x equals, horizontal lines are y equals. Do you remember that? right? If I want to write the equation of a line that's vertical, it's x equals some number. If I want to draw an equation of a line that's horizontal, it's y equals some number. So the first thing we're going to do is find this axis of symmetry. All right, so in this equation, the axis of symmetry, to find what x is, it's negative b over 2a. So in this equation, you could also read this, the opposite of b. So what's the opposite of b? Negative 8 over 2 times a. And what's a? 4. So I have negative 8 over 8. So x is equal to negative 1, because negative 8 divided by 8 is negative 1, right? So on my graph, let me go down here for a second. On my graph, I'm going to make a vertical line at negative 1. That's going to be my axis of symmetry. Okay, so I know my parabola is going to be exactly reflected across that line. All right? And is my parabola going to point up or down? Up. So I know a lot about it already. I know it's going to look like this. I know where the middle is. Now I just have to find the vertex. And if the vertex is on the axis of symmetry, what is going to be the x ordered of the ordered pair? If it has to be on the axis of symmetry, then x has got to equal what? Negative 1, right? So if I know x is equal to negative 1, then I can just plug it in and find out what y equals. So y equals 4 times negative 1 squared plus 8 times negative 1 plus 3. Okay? According to order of operations, what am I going to do first? Exponents or multiply? Exponents. So negative 1 squared is 1 times 4 is 4 plus 8 times negative 1, negative 8 plus 3. So that's 4 plus negative 8 is negative 4. Negative 4 plus 3 is negative 1. So my y is negative 1. My x is negative 1. It won't always be the same. That would just work out that way. So my vertex is at negative 1, negative 1. All right, so I go down here, and I graph a vertex at negative 1, negative 1, which is right there, right? Okay, now like I said, I need another point, because I don't know if this parabola is going to be like skinny like this or fat like this. I don't know how it's, so I need 2 more points to see how I'm going to draw the circle. So the easiest point to draw is the y-intercept, because if you think about it, if y-intercepts are where x is 0, right? Anywhere on this line is an x 0. So if I plug in 0 in this term, what do I get? 0. If I plug 0 in here, what do I get? 0. So what's left? 3. So it's the y-intercept is always 0 and then whatever c is. So in this case, it's going to be 0, 3. So I go over 0, up 3. So there's my y-intercept. And remember, there's a mirror image on the other side. So now I have 3 points, and I can kind of sketch in my parabola. Okay? So far, so good? Let me do, we'll go back and do another example of this, but let me do a vertex one real quick, because it goes quick. It's much faster. So the vertex of my parabola is at HK. So in this equation, what's H? 3. Good. What's K? 1. So my vertex is at 3, 1. what's my axis of symmetry? X equals what? Well, what's H? 3. So my axis of symmetry is at 3. Okay? And then I'm going to find my y-intercept the same way. I'm going to plug 0 in, and it's just a little harder there. You have to plug 0 in and calculate your y, and then make another one. All right? So for sure, try the standard form ones, and then I feel like the vertex ones will be easier, but no, because remember, it's just like the circles, because it's x minus h. All right, here's your homework. If you didn't get one, I have some back here too. You feeling okay today? Yeah? Look, your color is better today. Anybody else need one? Not get one? Yes.
I did most of them. There were still a few that I didn't get. So is it okay if I just like take it really fast as we get in class tomorrow?
Yeah.
Thank you.
Anybody else need one? Not get one? Sorry. Anybody? I knew I was going to be dressed up today. Got one? Ladies, you got one? Everybody got one?
I mean your hair, but I saw you guys yesterday at the track meet, and I was like, oh, I don't know if you just save them for the next.
No, thanks.
They're so good. Oh my god.
I didn't know I was supposed to be protecting those. I could have. 12th period, I have some crazy kids. Okay. Wow. Nice. Good. Okay, I'll run them down to the teacher's lounge right now, and or I might even just because Mr. Geiger is in the math department. Oh, wow. Nice. I may just leave him in the math office because Mr. Geiger's there. Do you want to come and get that stuff later? Do you want your?
Do you think he might still like need these for something else?
Possible. But you have the money, right?
Yeah.
Okay. All right.
Dang, I think all of Tim's cookies are gone. There's some chocolate chip ones left.
Yeah. A couple of my brownies. All right. Yeah. Nice. Good.
Oh, thank you very much.
Yeah. Good job.
No, thank you for working at the track meet. I mean, that was 50 right there.
Yeah. Yeah. So that's like 100 almost.
Yeah.
I think that's good.
We might have even reached 100. I lost count at the end.
Okay.
So,
Nice.
yeah.
Good.